And good afternoon, and welcome to Chapter 5. Today we are going to talk about OSPF. I know we discussed it last semester, but this semester we're going to talk about how to do a little bit of advanced OSPF by going in and adjusting some um, priority numbers, for example, and some fine-tuning OSPF, getting to it. So you'll see how to actually have some control and some troubleshooting skills on how to troubleshoot and work with OSPF. And you'll see why OSPF is the most widely used or most widely deployed routing protocol that is out there. All right, so we'll talk about the advanced single area OSPF implementation, which really means we'll get into details about how designated router and the backup designated router works, and we'll do a little bit of troubleshooting towards the end. What commands do you need to figure out where the problem is? Okay, so here are all the objectives that you're going to be looking at. It's really pretty much the version 3 for the IPv6 in terms of implementation. It's a little bit easier actually than version 2. All right, and we'll see all of that as we go along. So we'll model. All right. All right, let's begin. So routing versus switching. So when we talk about switching, when we talked about switching last week, and I mean a couple of weeks ago, talked about link aggregations. We need LAN redundancy, wireless LANs. All of that is within the local area network. Well, actually, you can go outside. So we want to have, uh, right? So all of that is within the LAN. When you get out of the LAN and you want to expand, you want to connect your LAN to another LAN, all right? When you to have a scalable network, you want to make sure that you can reach the other sites, you know, as quickly as possible without any problems. And if there is any links at the layer 3 between the routers, the routing protocols such as OSPF is the one that will get you to your final destination. So OSPF acts like what the STP did for layer 2, right? So they operate between the distribution and the core layer, not at the access layer like STP did, right? All right, so static routing. What does static routing mean? Static routing means you're going to go to R1 and you're going to say to R1, IP route, because R1 right now, he only knows that network 192.168.10.0, 11.0/24, and this link is attached to him. So if PC1 wants to ping PC3, he doesn't have that in his routing table. So you can go in and type a static route on how to reach the 10.110 network. So you can type IP route 10.110 with subnot mask 255.255.255.0, exit the serial interface. And you have to type another IP route to reach this network. And then you have to go over here and type an IP route to reach the other two networks. All right, so static routing is when the administrator types in the static route. It types in the route in the routing table. Okay, so that's easy, pretty straightforward. Now, if you have a very large network, it becomes a little bit cumbersome. It becomes a little bit difficult to go around and trying to find the best route to the destination, and you have to get involved and type that in. You don't really want that. All right. The default route means that what happens if I get a packet from outside or from anywhere, and I go through my routing table and it did, the destination IP address that was typed on that packet did not match any of the entries in the routing table. What do I do with that packet? Well, by default, you can either, send it out to the internet. And if you remember, the command for that is IP route, the quad zeros, and you can use the exit interface to go out here. Right? We'll discuss a little bit more about that later on. Now, what dynamic routing protocols do is like we did with RIP2 and OSPF last semester, you just activate the routing protocol on the router, and then you say what networks you want to advertise. So you do that on both sides, and what they do is they pass it to each other, and they build their own routing table. And if there's any other links, if there's any problems with the links, they recalculate another route. They'll reroute themselves. So OSPF, RIP2, the EIGRP, which we'll be discussing in chapter 7 and 8, all of these are dynamic routing protocols. They run by themselves and they pass updates to each other to and they choose the best route to the destination. And they converge very fast. Convergence means being able to find another route very quickly if something goes wrong, if a link goes down, for example. All right, configuring a single OSPF. If you remember last semester, we went to the interface gigabit. For example, you go to the interface on R1. And first of all, by the way, if you remember when we talked about OSPF, we said that OSPF uses bandwidth as the best route for the best route to the destination. So if it chooses the fastest link to the destination. Now, because most of these, the default is, by the way, they assume that everything is 100 megabits per second. So what they do is, so you want to make sure you go to the gigabit Ethernet right here and say your bandwidth is 1 million, 1,000. You put 1,000 and it already takes out whatever the bandwidth, multiply that by 1,000. So make sure that this bandwidth is 1 gigabit, because otherwise, if you don't do anything, the routers will assume it's a fast Ethernet, which is 100 megabits per second. Exactly. So that's what this bandwidth means. If you have anything other than 100 megabits per second, you got to type the word bandwidth on the interface to indicate that. Is that clear? All right, so that's the first thing you do. Then you go in and you say router OSPF, give it a router ID. We'll talk about router IDs later on. And then you got to go and say auto cost reference bandwidth is 1,000, because when OSPF wants to calculate the best route to the destination, it's going to take a look at the interface and take the auto cost and divide it by whatever the bandwidth is. So let me give you an example of what I'm talking about. So where can I write? I need to write someplace. So let me minimize all this stuff. Let me just go in here and I'm going to show you something. This is an example that we did many years for 203. Let me, I just want to type something up. Let me make the font very, very large. So let's say, while we're discussing this, I'll just move this over and bring this over so you'll see what I'm talking about. I'm going to move that over as well. Okay. So auto reference means, oops, let me just do a quick slide. So auto cost reference means by default, the auto cost reference auto cost reference dash bandwidth is 100 megabits per second. Okay, it's 100 megabits per second. That's the default. Well, I should say the default reference bandwidth is 100 megabits per second. For example, so what it does is when it wants to calculate the best route to the destination, the cost is going to be equal to the reference bandwidth, which is to the reference bandwidth divided by the actual bandwidth. Okay, let me just lower this a little bit so this way you'll see what I'm talking about. Let's just make this a 20, maybe you can see. So what that means, oh God, my spelling is horrible. Okay, so here's an example. Let's say I go to this interface and it was, well, they're all gigabit Ethernet. Let's assume this was a fast Ethernet, right? So the cost is going to equal to the reference bandwidth is 100 million, right? Because that's a divided by fast Ethernet is 100 million also. And that will equal to 1. Now, if this was gigabit Ethernet and I just changed the bandwidth to 1,000, so the cost is going to be, this is for fast Ethernet. Fast Ethernet, right? So that's the cost for fast Ethernet. That's assuming that you leave the interface at the, now that the bandwidth is, you assume that the interface is 100 megabits per second. Now, if you leave the reference bandwidth the same, right? And you say, hey, I got a bandwidth of a gigabit Ethernet. So it's going to be divided by 1 billion, right? So here's a billion. Just going to show you a simple example. I know it's taking a little bit of time, but this is important to see because we haven't seen this last semester. So 100 million divided by a billion, you get something like 0.100 whatever, right? 0.00, 1 over 1,000, right? 0.001. Oh, okay, so that automatically the router, because it's less than 1, it's going to assume it's 1. So it's going to calculate that 1 for the gigabit Ethernet. And that's not good. All right. So it's going to assume it's like a gigabit Ethernet, the cost on this link or on this link, even though it's gigabit Ethernet. But if we change the reference bandwidth to, if we say auto cost, if we change the reference bandwidth bandwidth to, let's say, a gigabit, which means you use the command this. What they did, auto cost reference bandwidth 1,000. So when you write this right here, so what you're doing is this going to take 1,000 times the default. So this will immediately makes the reference bandwidth makes the bandwidth equal to 1 billion. Follow? So now when I divide a billion by a billion, I get a 1 for the gigabit. But if I divide a billion for a fast Ethernet, the cost is going to be higher. And usually what Ethernet does, what OSPF does, it's going to look for the lowest cost. So if I have a gigabit Ethernet, I want to make sure it's 1. The fast Ethernet will get a 10 then for all of them. So make sure you do on all of the routers. You make the the cost reference multiplied by 1,000. So if you take 1,000, you're going to multiply it by the original 100 megabits per second. Is that clear? So you look at the fastest link on your topology, on your area, and then you change the auto cost reference and multiply by, if this is a gigabit, the fastest one is 10 gigabit, you multiply it by 10,000. If the fastest is gigabit, then you multiply it by 1,000. If everybody is fast Ethernet or less, you don't have to do this then, right? Makes sense? But also, if anything is faster than fast Ethernet, you got to go to that interface first and make sure, and let me blow this up, and make sure that you do bandwidth on that interface first. All right, we're going to practice some of this when we do our OSPF configuration later on. So question number one, I want you to, and the question is, how do you change the reference bandwidth for OSPF? And the answer is this. I want you to write this down and submit that as question one for homework. All right. So give me 1 second. Okay. Okay. So we got question one out of the way. All right. Let's continue. Now we know how to set up the reference bandwidth. Also, we already know how to after you do router OSPF, every interface must be assigned a router ID. So a router ID is really nothing but an IP address, so just make it simple. For example, 1111 here, 2222 on this one, 333 on the other one. They got to be different. And we'll discuss the importance of the router ID. When you do that, you have to be in router OSPF. And then you advertise your network. Here's the network. And this is the wildcard. And how do we calculate the wildcard? By taking 4 255s minus the subnot mask, and that's how you get this. So this must have been a /24. And don't forget, you have to write area 0. What's passive interface gigabit 0/0? You do not want any OSPF updates to come through, right? We did all of this except we didn't discuss the auto reference, the auto cost reference bandwidth last semester, but this is basically, we did that last semester when we configured OSPF version 2. All right, so how do you verify the single area OSPF? Just type show IP OSPF. So when you see it's making neighbors, it's being full, that means they have already established the neighbor and they already passed updates to each other, so we're all good to go. Show IP protocols gives you that what OSPF is running and what's the router ID, what networks are being advertised are down here. So those are the 3 networks on router 1 that are being advertised. And here's your neighbors, right? I'm getting information from my neighbors. Remember, the administrative distance for OSPF is 110. Anybody remembers what the administrative distance is? Well, that's question number 2. The administrative distance is shows the reliability or the trustworthiness of the route. The lower the number, the more reliable the route is. By default, OSPF has an administrative distance of 110. RIP2 has 120, EIGRP has 90. Okay, so an example. I'll give you an example again. If you have one router that's running all 3 protocols, RIP2, EIGRP, and OSPF, the router will load EIGRP in the routing table and will not do anything for RIP2. We'll leave RIP2 and OSPF alone. And why is that? Because EIGRP by default has a lower administrative distance. By the way, we can change that number. It doesn't have to be. But we'll discuss that some other time when we get to EIGRP maybe. All right, if you type show IP OSPF, this will show you the router ID number if you ever needed that, right? It will tell you when it's the last time it went up. And you are in area 0. That's what backbone 0 means. The reference bandwidth is 1,000 megabits per second. It means gigabit, right? So that's all good. All right, show IP OSPF interface. Again, it gives you the IP address. You're in area 0. It gives you the designated router, who's the designated router is, what's your priority in. Well, this guy is also a designated router, which we'll discuss that in a few. Show IP OSPF interface brief. It's going to show you all the interfaces, what their IP addresses are, what area you are in, what state, if you are a designated, this guy is the designated router side. The other two are serial ports, they're point to point, right? All right. All right, configuring OSPF for IPv6. Pretty much when it comes down to the router ID, you have to do it on OSPF version 4. In version 2 for IPv4, you don't have to do the router ID. This will, if you don't type in this command in version 4, um, it will automatically do it for you. But in version 6, you must um, configure the router IDs on the router. Okay, so you do that. Do your auto cost reference bandwidth because we have some gigabits Ethernet. Then you go to the interface, change the bandwidth, make sure it knows that the bandwidth is 1,000. By the way, when you type 100, the bandwidth is 1 million right here. You're going to multiply it by 1,000. So when you write the word bandwidth, whatever number you write will automatically be multiplied by 1,000. So if you know that this is a gigabit, so if you know that this is going to be a gigabit, so just write bandwidth a million. And then a million, because the router will automatically multiply by 1,000, you'll have your gigabit. All right, then all you have to do is then say IPv6 OSPF 10, you're in area 0. And then you go to the other interfaces, you say IPv6 OSPF 10 area 0, and you do the same thing here, right? But you got to do this first, IPv6 router OSPF, and put the router ID. And you should do the reference bandwidth too as well. You do that on all sides and you're all good to go. And that's it. All right, so the commands that you use to verify single area for OSPF version 3 is pretty much the same. Same ones that you have used for version 4. Okay. Now, what type of OSPF networks are there? You can have two routers that are directly connected to each other, point to point, broadcast multi-access router interconnected over an Ethernet network, non-broadcast multi-access when you are connected to a frame relay. If you remember well, no, you guys don't remember. When we do frame relay, OSPF never goes because frame relay does not broadcast anything. It'll make copies, but it doesn't broadcast. Point to multi-point, that means one router sending it to multiple routers or virtual links, and that's we'll discuss next week when we talk about multi-area OSPF, when one area wants to go through another area and we'll go through area 0 as a virtual link. So we'll discuss more of that. We'll do a non-broadcast multi-access or a broadcast multi-access network, and we'll see how that works. So it's pretty good, something like this. And this is what makes OSPF famous, because they can set it up so easily this way, and the configuration is not that bad. Anyway, so multi-access networks create is two challenges. The problem is when I send an update, because this is going to be a broadcast and the switch will send it to everybody, it's trying to make adjacencies to everyone. So I have to make adjacency with 3 routers now, and he has to make adjacencies with 3 routers, and so does he. All right, so everybody has to send updates. You have to create 6 adjacencies if you have 4 routers, and it grows. So the number of, if you have 5 or 6 or 7, as you can see, the number grows dramatically, and that means the network is going to take a long time to converge because they have to talk to each other and build their routing tables. That's what that means. So sending updates to each other, the more routers in a multicast access network, the longer it's going to take for the network to converge. So the solution is to create a designated router and a backup designated router. And the idea is you say, all right, out of the whole, let's say these 4 routers that we just looked at a few seconds ago, let's go back to it, in fact. So what they go into do says, hey, listen, instead of me sending updates to everybody, and you send updates to everybody, and R2 sends updates to everybody, and so is R3, what we're going to do, here's what we're going to do. We are going to pick one of us. We're going to elect one of us as a designated router, and we'll pick another guy as the backup designated router. And what that means is, let's assume that R1 was elected as the designated router. So all of us, R2, 3, and 4, will send our updates to R1. And then R1 will send all the updates to everybody else, right? So R4 will send the updates to the designated router, and so is R2. So R1 will be the host that will take all the updates from everybody, and then R1 will send the updates back to everyone else, so they can calculate their best route, the best route to the routing table. And this, speeds up the convergence time so that the routers can build their routing tables very quickly. All right. So when you have a multi-access network, everyone is attached to a switch. The routers will automatically uh, try to elect a designated and a backup, just in case if the designated router goes out, the backup will take over. Anyone that has not been elect or did not get elected as the designated or a backup designated, then he becomes a non-backup designated router and a non-DR, and we actually call them DR others. So any router that you see the word next to it, DR others, that means that router is not a designated router or a backup designated router. Now, the DR others, all the other routers that are not designated, they send their updates to the DR using this address, this multicast address. Remember class D, excuse me. And then when DR finishes, he will use the .5, the multicast address 224.0.0.5 to send it to everybody else. So .6 is what everybody sends to the DR. .5 is what the DR sends to everyone else. Okay? Okay. So question number 3. How do OSPF resolves the problem of adjacencies in a multicast address topology? That's question number 3. And the answer is by designating a router and a backup designated router to receive all the updates. Okay? So the routers will elect a designated and a backup designated router. All right, so here's a typical connection. And let's say R2 was the designated router, and this guy is the backup designated router. So what these guys do is they send their updates to him, to R2. And of course, the backup. This guy doesn't do anything, but it's the job of the designated router to send back on the .5 address to everyone else, right? How do you verify that you have a designated and a backup designated router? Show IP OSPF gigabit 0/0. That shows that you are in the others and you have a priority as 1. We'll take a look at that. And this guy is not a designated router, right? Or a backup. See that? His designated router is this guy. He has this router ID and at this address. And the backup designated router, that's his router ID number and through this interface. Okay? All right. State neighboring. When you type show IP OSPF neighbor and you see this and you see 22222 full backup designated router, that means 22222 is your backup designated router. And he is attached to this interface. And the designated router is attached to you, has this IP address, right? From your gigabit Ethernet. Came in from your gigabit Ethernet. So that's the IP address of your backup designated router, and this is your IP address of your designated router, and these two are the router ID numbers. This is the router ID of the backup, and this is the router ID of the designated router itself. Okay, that means it made full adjacencies, and we are in full operation. All right, how does the election process works? Let's see all these routers together in that multicast address. And what they do is they look first which router has the highest interface priority number. So by default, all the routers have an OS priority number equal to 1. All right. So the best thing to do is if you change one router, see that router 2 over there? Let me just go back right here. I just want to go back to the topology. So R2, if I go and say, hey, R2, I'm going to change your priority number to 255. And then and make this guy, let's say 250, lower than the designated router priority number. These three are 1, 5, and 4. They all still have the default priority number, which is equal to 1. So when the elections occur, who's going to win? The DR. And who's the vice president? The backup DR. Right? So by changing the priority number, you can manipulate the election. That's the easiest way to make sure you know which router is going to be the designated or the backup designated. If you don't, then let's say you leave the priority number the same. Then he says, hey, we all have the same priority number. We still need to create a designated and a backup designated router. We still need to elect one. So what they do is they look for every router's, then we say, hey, give me your router ID number. So the router starts passing their router ID numbers to each other, and the guy with the highest router ID number wins. That's it, assuming that the priority number is the same. So if R1 happens to have a router ID higher than everyone else, then that's the case. That's why we type in router ID on all of these. Now, what happens is you don't, because remember I told you earlier, you don't have to configure the routers with router IDs. Remember, you type router-ID. We said 1.1.1.1, 2.2.2.2, 3.3.3, 4.4.4, 5.5.5. So 5.5.5.5 would win if we statically configured the router ID. The one with the 5.5.5.5 would win, right? And the 4.4.4.4 would be the backup designated router. But what happened if you did not configure the routers with router IDs? Well, how does the router IDs configure? By the way, OSPF, when you first turn your router on, they'll say, hey, wait a second. The first thing we got to do, because I'm running OSPF, I'm a router, I need a router ID. I need a badge to be able to communicate with my friends in my OSPF multicast address, multi-access. So what they do is they say, did anybody give me a router ID number? If the administrator never typed the command router-ID 111 or 2222, then the router says, wait a second, and nobody gave me a router ID number. What it does is it goes and says, I'm going to look to see if there's any loopback addresses being configured on me. If there's a loopback address, a whole bunch of loopback addresses, he's going to pick the highest loopback address configured and use that as the router ID number. Now, if there's no loopback address configured either, the router will look at all the interfaces that are running on it, configured on it, and active, and choose the highest one as the router ID number. Is that clear? So, therefore, if you do not do anything and you just configure OSPF, the router is going to choose the router ID number automatically by picking the highest active physical interface as your router ID number. And if you leave that alone, then the routers will pick the one with the highest router ID number and he would win. So it could be this guy that has the highest active interface, and you don't want to do that. Okay, so let's go back in here. This really describes the backup, the designated router, and the backup designated router election. All right, so I want you, is question number 4. All right, I want you to write all of these bullets down. So type these up and send them in as question number 3. So will tell you, this is very important because it gives you step by step how the router elects a designated router and a backup designated router. I think this is written pretty well. So the first thing that it's going to do is the router with the highest priority number wins. By the way, that's the easiest way to do it. So you type IP OSPF priority and you give it a number between 0 and 255. By default, by the way, everyone is 1. If you give a router a priority equal to 0, you know that that router will never be elected. Let's say you pick the router and you say, all right, I don't want this guy to be elected. I don't care who in the network gets elected, but I don't want router number 2. So what you do is you go there and you say OSPF priority equal to 0. You leave everyone else equal to 1, and they just make their elections and they'll pick somebody else other than router 2. All right? Now, if you leave the priority number for everybody to be 1, then they have to pick up, they're going to use the router ID number to elect the DR. Okay? Now, the router ID number could be done in 3 different ways, right? Either can be configured manually using the router ID. If not configured, you have to have, it's going to pick the highest loopback address. If there's new loopback addresses, you are going to determine the highest, determine the router ID by looking at the highest active IPv4 address. All right. And remember, you have to do this in IPv6, the router ID. You must configure that. And in IPv4, you don't have to do that because it will go to step 2 and step 3. In IPv6, there is no step 2 and step 3 to figure out what the router ID number. You have to have a router ID number typed manually. All right, so write that down, all of this stuff for question number 4. All right, now, once we done with the elections, what happens if the DR fails? Of course, the backup takes over and an election will happen for the backup. Okay, in fact, if you have, and what happens if the DR comes back? Well, he joins in the network. If anybody comes back and you have already a converged network, which means you already have a designated and a backup designated router, there is no reason to restart the elections all over again. You leave them alone, right? Only if the DR and the backup DR goes down that will have an election. What happens if you want to change that? So what you do is you go change the priorities and shut down the interfaces that are facing the multicast address, starting with shut them all down, and then you turn them back on, typing no shut, starting with the one that you want it to be the DR. You go to that interface, no shut, you go to the backup, no shut, and then no shut on everybody else, and a new election will occur, and then you, DR, will be elected then. Okay, how do you change the OSPF priority? Go to that gigabit Ethernet interface that's facing the switch, and you say IP OSPF priority, and you change that number accordingly, right? So you can do that on the interface itself. Okay. Propagating the default gateway. So let's say this router, or if you don't have the default gateway, what is the default route? Not default gateway. Default route means, that means if a packet comes into the router and the router looks up the routing table and nothing matched, the packet is going to get dropped if there is no default route. So what you do is you type in IP route quad zeros. This IP address is the next hop address, which is your service provider. So now, if you have this route in your routing table, that means if a packet does not match any of the packets in the routing table, that packet will go to the internet, right? Now, what the router 2 does then, he'll say, hey, I have a default route. It's going to go into OSPF 10 and tell his neighbors, everybody that is running OSPF 10, the default information originate. What that does, it will send an update to the other 2 routers telling them, listen, you don't have to create a default route on your routing table. I want your default route to be connected to me, R2, okay? So R1 and R3 down there, if they what they're going to do when they hear this default information originate, what they do is they immediately create a default route in their routing table pointing to R2. so that if on R1 or R3 a packet comes in and it doesn't match the routing table, they immediately send it to R2. And what does R2 do? Send it to the internet. So what you really did is everybody will go through the internet through R2, which is nice, right? So default information originate is to propagate the default route from one router to all other routers that are running OSPF, right? And typically where, who does that? It's the router that has a default route, an actual default route. He's the one that sends out the default information originate to everyone else. Okay, so when you type IP show IP route, it's going to look like this. This is on R2. He has an S with a star. That means his default gateway is connected. And the other routers will have, the S with it pointing to the loopback address. It could be or someone else. All right, so for IPv6, it's pretty much the same thing. All right, default information originate. No difference. The hello and dead time interval must match to be a neighbor. So here's another thing you need to remember. When you're all connected to that switch, routers by default, they send hello to each other. Say hello every 10 seconds, right? So all the routers by default, they have to say hello to everyone else every 10 seconds. And so routers, when you come in and say hello to me every 10 seconds, they say, all right, I also going to say hello to you every 10 seconds. So we both match the same hello interval. Dead interval means that if you did not come in and say hello after 4 times, I'm going to consider you as dead. You're no longer my neighbor. Is that clear? So me and you have to match what is the hello interval and what is the dead time interval. So if my hello interval is every 10 seconds I say hello to you, and I'll say I'm going to consider you to be dead after 40 seconds, and your hello interval is 5 seconds, and even if the dead time is 40, because your hello interval is not the same as mine, we're not neighbors. Is that clear? So they must match. By the way, sometimes you want to increase or decrease the hello and dead time intervals. You want to decrease them because you want the elections to happen very quickly and you want to converge very fast, right? But that creates traffic though. So we'll learn on how to change the hello and dead time intervals, all right? Later on when we do our configuration. And this is how you do it. I mean, we'll be able to do this. We'll say IP OSPF hello interval is 5, the dead time interval is 20, and you got to do it. You got to do it on all the interfaces, right? Because otherwise, if one is no good, it's not going to work. All right. Also, now routers have to be able to do authentications. So before we send any updates to each other, we are going to encrypt the updates using the message digest number 5, which is a pretty strong hashing algorithm. It's going to look at the data and just send the number to match it. All right. So think of it as really sending data encrypted. So this way to make sure that not another router comes in and joins in the area and starts sending and receiving bogus updates or make himself an elected, a designated router. So all the routers in the area will not send any clear text in their updates. They'll be encrypted using the message digest. All right, and we'll take a look on how to do that too. Well, here's how you do it. If you want to do it on the global level, so you go to R1 and you say area 0 authentication message digest and you type in, you say exit. Then you go to every interface on your router and you say IP OSPF the message digest key number 1 using MD number 5, and here is the password. So you do that, same password, same command on all of them. But this command goes in first on the global, and then you take this command on every single interface. Now you can go interface by interface. You don't want to do it to everybody. So you go only to the gigabit Ethernet and you can type these two commands. You can say IP OSPF message digest 1 MD5 with the password, but then you got to say IP OSPF authentication message digest is what's going to be used. Either both are okay. I mean, I've done both. You're not really saving too much time. It's either you can do it on an interface level or the global level. All right, verifying that OSPF MD5 is working, you type show IP OSPF interface serial 000, and you'll see it down here that's been enabled. So you know that your router now using authentications before they send and receive any updates to each other. Okay, how do you, okay, of course you got to type show IP route, display the routing table, and see if OSPF is getting it, right? All right, when you are troubleshooting, here's your final section, troubleshooting the OSPF, the single area OSPF. So you can have many different problems. You know, OSPF types do not work. The hello packet and dead time interval dead timers are not the same. I remember when I took my CCNA, I had two routers that are running OSPF, but the hello interval on one was 20 and the other one was 40. And you have to figure, you know, you have to type in the commands to figure out where the hello packets are. And then they will immediately was able to notice that, and that's the answer, of course, because the hello intervals did not match, therefore they did not have adjacencies, right? The interfaces may be not configured correctly or set up as passive. So if you put a passive interface, that means no updates leave here. Not good, right? Authentication is misconfigured. If they have a password here different than the password on R2, it's not going to work either, right? So you got to look out for all of these stuff. The interfaces are not on the same network, not in the same area, different subnets, maybe, right? All right, when you're transitioning via OSPF states to establish a neighbor, you go from down states when you're off, the initial state, two-way state, and when you're synchronizing the database, you go through these states to get into full. All right, the commands that you're going to need, these are very good commands to practice with when we do their configuration. Show IP protocols, it's going to tell you if you have OSPF is running or not. We looked at show IP OSPF neighbors, show IP OSPF interface, will give you your router ID number. Show IP OSPF will give you your router ID number too, and the process ID, that number 10, you know, when you type router OSPF 10. Show IP route OSPF will display only the OSPF in the routing tables. You know, you'll ignore all the connected or static routes that are in there. Okay. Clear IP OSPF, the process ID, clear everything, and let's start from scratch. You use this command when you want to change, you want to shut down all the interfaces because you want a new election to happen. So you clear all the OSPF, you know, clear IP OSPF, the router number 10, the process ID number 10, and you say process. And it's going to reset the whole thing, right? So you can type it, you can troubleshoot, is the routing table correct? So you can use some of these commands. Does the traffic take the desired path? You can, if no, you can troubleshoot. You can use any of these commands to do that for you. All right. All right, you can verify active OSPF using the show IP OSPF interface. So all of these are different commands that you should use. And you should, when we finish with our packet tracer today, you should use these commands, even though I'll leave it up to you to do that. And try to play around with some of these commands and see what the output is, right? So you can tell, you know, if we are doing it right or wrong. All right, so we've done some of this, and we'll see for IP version 6, it's pretty much the same thing for IPv6, right? All the commands are pretty much the same. All right, so now we are ready to do our packet tracer. But before we do that, I'm going to go in and grab a cup of water. Just give me a second, guys. Okay, I'm back. So now I want you to open up a packet tracer. We'll just blow it up really big. And let's bring in a switch, a 2960 switch. And let's bring in routers. Let's bring in, you know what? Let's bring in 2811, another 2811 that has fast Ethernets on this side. And let's bring in a 1941, because I know it has a gigabit Ethernet in here. Let's call this R1. Let's call the one on the top as R2. And let's call this guy R3. Okay. All right. Now let's connect these. Connect R1 with gigabit to fast Ethernet 01. Let's connect R2 fast Ethernet 00 to 02. And this one, let's connect it to fast Ethernet to 03. All right, now let's bring in some PCs. Bring in a generic PC here, another one up here, and another one right here. All right, straight, nope, we need a crossover cable. Let's go from the fast Ethernet to the gigabit 01. And let's go from here, from the fast Ethernet to the gigabit 01. And let's go from here to the fast Ethernet 012. All right. Okay, so here's what we're going to do. We're going to say you are going to be network 192.168.10.0 with /24. We are going to say this network up here is 192.168.11.0/24. And we're going to say this network right here is 192.168.10.12.0/24. All right, and this whole multi-access network, these three interfaces will be, let's say, 172.16.100.0, and let's say it's /28. All right, that means it's going to have 240 at the end. Okay, so let's start configuring the interfaces. Let's just go with the PCs first. So let me click right here, click on the PCs, the first address. So it's 192.168.10.1/24. And let's use the last address as the default gateway in the network. Okay, let's go to PC. Let's make this PCA. So this way I can differentiate between them. PCB. And this is PCC. Okay, so let's go right here, desktop, and put in the IP address. No, not .10.11.1. And it's 192.168.11.254. Right? And this one will be the .12. 192.168.12.1. 192.168.12.254. Okay. Let's just do the basic interfaces. And let's go right here and go to CLI. Remember, you have to do this and you have to submit that as homework for chapter 5, right? So make sure you're doing this with me. En config T. Let's just do the basic configuration. No IP domain lookup. And the host name of R1, right? Let me go to the interface gigabit 0/0, which is this guy right here, and say IP add 192.168.10.254 space 255, 255, 255.0, and you say no shot. Now it went up, but oh, I get the wrong one. Oh, jeez. This is the 00, and this is on 01. Oh God, this is 01. What's this? 01. Oh, 01 is the one that's facing the LAN. Okay, so here's how I fix that. say no IP add, right? I'm going to take that IP add down, and in fact, I'm going to shut it down, 00. I'll get to that later on. Let me go in interface 0/1, not fast Ethernet, G01, right? G01, and say that the IP add is 192.168.10.254, 255, 255, 255.0, and then you say no shot. Okay, now it's up. All right, so the 01 is up. Now I can go back to the fast Ethernet interface, gigabit 0/0, and say that the IP add is 172.16.100. Let's say this guy .1, right? And it's /28, so here's /28.240. And I say no shot. Okay, now I go to, I'm just going to minimize that. Let me go to R2 up here. And I'm going to say no. And I'm going to say enable. Config T. No IP domain. Lookup. And the host name of R2. I'm going to interface G0/1. Invalid. Oh, it's not G. Interface. This is fast Ethernet 01, right? Yeah, this is FA01. This is FA00. Okay. INT FA0/1. Oh, God. It's getting late. IP add 192.168.11.254. 255, 255, 255.0/24, right? And then you say no shots. Then you go to interface fast Ethernet 0/0, and you give it the IP add 172.16.100.2. Because he got .1, he's in the same LAN, so he gets .2, right? 255, 255, 255, 240, and say no shot. Okay, so he joins in the crowd now. Now let's go to this router, R3, and say no. En config T, no IP domain lookup, and a host name of R3. And then you go into phase 0/1, and you say that the IP add is 192.168.12.254, 55, 255. No, too many 255s, right? No, that's right. .0. And then you say no shot. And then you go to interface fast Ethernet 0/0. And you say that the IP add is 172.16.100.3. 255, 255, 255.240. And then you may say no shot. All right, so we have the basic configuration set up. So now we're going to run OSPF on those interfaces. All right, so the first thing I'm going to do is I'm going to change the bandwidth on these guys, right? So let me go to, so here's stuff, because I know that this is a gigabit Ethernet. I want to make sure that they know that this is, by the way, if you don't know how to do that, so you're going to say here, well, we're not running OSPF. We're not going to be able to do that. So how do you reflect a gigabit Ethernet right here? Let me go to interface G0/0, both of them, by the way, right? And you say bandwidth and 1000. So now you do the same thing for 01. and the bandwidth is 1000. So now they know that this is gigabit Ethernet, right? And now we're going to make sure that when we do order cost, tell OSPF that make the reference bandwidth multiplied by 1000, right? So we changed that reference cost that we talked about earlier. So now you leave the others alone because you don't have to change the bandwidth because they're not gigabit. So that's fine. They're fast Ethernet and that's okay. They'll be able to pick that up. So now what we're going to do is we are going to run type exit. We're going to do OSPF. Just do regular OSPF like we did. So let's say we say router OSPF, and let's use the process ID number 10. All right, let's give this guy a router ID. You know what? Let's not do a router ID because we don't have to do that. Correct? So let's not do that for now. Let's just do the auto. Let's not do the order cost either, right? Let's just router OSPF and say network. Now, here's a trick that we did not do last semester. Instead of typing the network address and the wildcard, what you could do, use something new, is you type the interface, this interface right here, and you type in, let's say that interface was 192.168.10.254. And if you write in a wildcard of 4 zeros, and then you say area 0, what that does, when you type in this IP address on the interface and you type in a wildcard of quad 0, this is going to force OSPF to use the subnet mask that is on this interface, which really will automatically come up with the wildcard in this network for you. So you don't even have to figure out the wildcard anymore. But we went over it because I want you to learn how to do it. And you will see that when you, on your exams, of course, including the Cisco, CCENT and the CCNA test. All right, so let's go to this interface too. And we got to do network. And that interface is 172.16.100.1 0000 space area 0. Okay, we don't want any updates coming into the interface, so we say passive interface, fast Ethernet, not fast Ethernet, gigabit 0/1, because this is /1. By the way, if I type in gigabit 00, no updates will come out of here. And therefore, this guy is not going to participate in OSPF. So make sure that the passive interface is only blocking updates from going into the gigabit 01. What does that mean? That means this interface will not send any hello packets out of here. And therefore, it will not make adjacencies with anybody here. If you do not make it a passive and it's an active OSPF, it'll be sending out hello packets to these guys. So we want this guy to participate in OSPF. So do not make this interface as passive. And by the way, if you typed passive interface and you write the word default right here instead of G0 default, that will make all the interfaces passive. So usually we do that and then we'll just, we'll say, default on all the interfaces and we'll just go pick the one that we want and say no passive interface G00, and then we know everybody else is turned on. It's a quick way of doing it, turned off. All right, so that's that. Let's go to R2. Do pretty much the same thing. Type exit and say router OSPF number 10. And the network we're going to do is 192.168.11.254. I'm going to use that way of doing it. And quad zeros and say area 0. And the one inside is network 172.16.100.2 with also quad zeros. area 0. And we're going to do the passive interface on the fast Ethernet 0/1. That's this guy right here, right? All right, so now we're going to go into router 3. And we're going to run OSPF. So what are we going to do? Router OSPF 10. And we're going to say the network 192.168.12.254 with the quad zeros, area 0. And we're going to say network 172.16.100.3 with the quad 0, area 0. And the passive interface, and the passive interface is on the fast Ethernet 0/1. All right, so if you do Control Z and you type show IP route. Uh-oh. I just saw it. Didn't it do full OSPF? Yeah, it's done. So show IP route, and there you go. Now they have established a route between them. So this is the network 10, and this is the, now notice the cost. See, it's 101. Because we never changed the auto cost right here. If you go to router 1, well, this should be able to ping each other. So here, if I go and type in, let me just do exit, and I'm going to do show IP OSPF interface, and let's say on the gigabit 0/0, right? That's this interface right here. See, the cost is 100, even though it's gigabit Ethernet, right? So we want to change. We want to change that. Here's the router ID. See, the router. By the way, also the router ID is 10, 192.168.10.24, which is this guy right here, because it shows the highest active interface, right? If I type loopback addresses on all of these, we'll see that the highest, then the router ID will be picked by the loopback address. So here's what I'm going to do first. I'm going to change the auto cost first on all of them. Okay. And then let's do that first. So let's go in and do config C and go to the router OSPF 10. And I'm going to say auto cost reference bandwidth is 1,000 here. Okay, so now we got to make sure we got to do it on all the routers. And now we're going to say, and this is pretty much the same thing, router OSPF 10, and you're going to say the auto cost reference bandwidth is 1,000. All right, let me go into router 3 and do the same thing. Do config G. Let's change the auto cost. Oops. Oh no, we got to do router OSPF 10. And then you're going to say the auto cost reference bandwidth is 1,000. Okay, so if I do Control Z and I do show IP OSPF and interface fast Ethernet 0/0. See, now the cost is has a cost 10. It should not be though. The auto cost has, let's see this auto cost and see what happened here. And this cost is 10. That's not supposed to be. This is supposed to be 100 now. Let's see what happens to router 2. Well, see, it changed it correctly here, right? Because now you have, it's supposed to be a 10, and these are supposed to be the 100s, right? Unless the order cost was what was changed. Now they're all 10s because these are fast Ethernet. The bandwidth was 100 megabits per second, right? Unless we say what the bandwidths are. So if I go in and type show IP OSPF interface fast Ethernet 0/0, still showing a 10, where it's not supposed to do that. All right, now the hello interval is 10 and the dead time interval is 20. So you know what? Let me go to the interfaces and say 1,000. But if I say it's a 1, the bandwidth then is what? Doesn't show. Things are making, let's see. All right, all trouble do that. Why are they showing still a cost of 10 even though the order cost is 1,000? All right, now here's what I'm going to do. I'm going to do loopback addresses. First of all, if you look right here, you'll also see that the designated router or the router ID, designated router is this guy. Or maybe I should say the router ID. You see, it used this right here, the highest interface. But when I create a loopback address, the router ID is going to pick the loopback address because that has precedence. So if I go right here and say config T, and I create a loopback, let's say just write LO0, and I'll just give it an IP add. Oops, an IP add. Let's give it 10, 20, 30, 40 address with was just like 4 255s, right? Oops, 4 255s. Okay, now if I do Control Z and I use the command on the G0, where is it here? The router ID is still the same though. It did not do it. I'm going to say show IP interface brief. I do have a loopback 0, and I'm going to do show IP OSPF interface G0/0, and the router ID has not changed. So packet tracer is screwing up with us because packet tracer is supposed to do that. All right, so another problem with packet tracer. It's not picking up the loopback as your router ID. Now, here's what we're going to do then. I'm going to give this the router ID manually so it changes. So I'm going to say config T, and I'm going to go say router OSPF number 10. Your router dash ID is 1.1.1.1, right? Now, if you want this, I have to reload. If you want the thing to take if you want the elections to happen all over again. But let me change the router OSPF on all of them. I mean the router ID. Let's go to router 2, config T, and you say router ID 2.2.2.2. Router dash ID should be. Okay. Did I say? Oh God. Router OSPF number 10. And then you say router ID 2.2.2.2. Okay, let me go to router 3 and say router OSPF number 10. Oh God. Let's do a config T first. And then you say router ID, router ID 3.3.3.3. What did I do? Oh God, I'm losing it. Router OSPF 10 first. And then you say router ID, the 333. All right, so if I do Control Z, and then I do show IP interface, show IP OSPF interface on the gigabit 0/0, show IP OSPF interface. This guy doesn't have gigabit. It has fast Ethernet. Oh God. Now we have to reboot to actually see this. So we'll go and start. We are going to say reload or use clear IP OSPF process. So let's use the command clear IP OSPF process. Clear IP OSPF number 10 process. Well, we got to do that here. Oh my God. At the privilege mode. Clear IP OSPF number 10 process. They don't like number 10, so get rid of it. And reset all OSPF processes, say yes. Okay, so let's do the same thing right here. Do Control Z, and we're going to say clear IP OSPF process. Say yes. And let's go to this router here and do the same thing. And we're going to say clear IP OSPF process. And say yes. So if you go back to router 1 and you type show IP OSPF interface on the G0, you see that the router ID is now 11111, right? If you go to router 2 and you'll see that the router ID is 22222, right? Good. So who is the designated router? If this is 1111, 22222, 3333, it's number 3. Who's the backup? R2. So this guy is should be see the designated router is 3333. He told us already. The backup designated router is 22222 ID, which is this guy. So now the router ID take over. How can you make sure that the router ID is the one who is determining who is the OSPF designated router? Because now he's the designated router because he has a higher router ID. Now they all have a priority equal to 1. So see, R2, R3, and R1 have priority 1. So let me go ahead and make this guy a priority equal to 200. And if I make his priority higher, then I know that he is going to win, right? So we'll deal with that later. So let me go to R2, and I'm going to make and say, let me go to this interface right here, to the fast Ethernet 00, config T, and I'm going to say, what am I going to say? IP OSPF, your priority is 255. I'm going to make it the highest. On the fast Ethernet 0 slash, did I go? Oh God, I got to go to the interface first. 0 slash, this interface right here. And then I go say IP OSPF priority is 255. So now he has the priority equal to 255. If I do show IP interface, show IP OSPF interface, fast Ethernet 0 slash 0, the priority number is 255, right? The process ID, the router is the backup. See, the designated router is still this, right? Let's say I want, because now we have to clear. Remember the clearing? And then we'll see who's the winner. So let me make him the backup designated router, right? So I'm going to go config T. I'm going to go to the interface G00, G0 slash 0. And I'm going to say IP OSPF. Your priority is number 200, lower than the other guy, right? Now remember, his priority number is still 1. So now he's going to lose. He's going to be the DR and he's going to be the backup DR. So, and how do you do that? You go by router 2 and you clear the process right here. You say yes. Go to router 1. Do Control Z. Let's do the clearing. Oops. Say yes. And let's go to router 3. Clear the process. Yes. Okay, now, if I go to, and watch, let's do it on RT. Show IP OSPF interface, the fast Ethernet 0 slash 0. Okay, where's the designated router? The designated router is now he's a DR others. You see that? Okay. His priority is still 1. He's no longer the backup designated router. If I go to this guy right here, now watch, who is the designated router? The .254, the 11.254. That's this guy right here, right? Because he has a higher. So if I go to router 2, and I'll see that, where is it? The priority number is 255, and the state is a designated router. This guy is the designated router, right? If you go to R1, you'll see that his state is the backup designated router because we changed the priority number on him. All right? Isn't that cool? And if you type show IP route, you see that the cost, unfortunately, the cost didn't work out for us. Now, what happens if you want to change the hello numbers or the interval numbers? So you see this hello and dead time intervals. So what you do is you go in here. Let's go in and change them to, to 5 and 20. Split these in half, right? On all of them because we want the network to converge fast. So what you do is you go to the interface that's facing the switch and you say config T. You go to the interface G0 slash 0 and you say IP OSPF. I want the hello interval to be 5 and I want the dead time interval to be 20. Okay. Now, if I clear the OSPF, he's going to lose everything because everybody else is what, 10 and 40. If I clear the IP OSPF process, but let me do the same thing on this guy. Config T. I'll go to the interface fast Ethernet 0/0, and then I say IP OSPF. I want the hello interval to be 5. They all have to match. And I want the dead time interval to be 20. What happened here? Oh, it's reloading. Okay. And this guy right here, I'm going to say config T. So he got detached because he lost his OSPF, his neighboring, right? See, the dead time interval expired. No good, right? That's a good example. So he's out because these two guys are okay. They have 5 and 10. So let's fix them up, right? So how do we fix them up? I'm going to go to the interface fast Ethernet 0/0, and I'm going to say IP OSPF. The hello interval is 5, and the dead time interval is 20. Now it should fix itself up. Bingo. Now it's fixed. Let me just make sure before that we are all good, right? Yeah, we're good. All right, going back. So now you can say we were able to. Oh, the only thing that we did not do is the authentication. Let's do some authentication on all of them. So let's learn how to do the authentication. Let's go to R1. We're almost done, guys. And make sure you're at the config mode. And you are going to say, let's do a global one on all of them, right? So you're going to say router OSPF. Um, you want to do it on all? You know what? Let's just do it on these interfaces right here, not global. So let's go to the interface, and this one is G0/0. I'm not going to do it on the global level because it should be only between these. It's going inside. And we're going to say IP OSPF. Okay, the message digest key number 1 is going to be MD5, and let's use the password Cisco123, right? And then you're going to say IPSPF message digest, and you're just going to say OSPF. Let me see if I'm missing anything. Key. Oh, it doesn't support that. It's key 1. Oh, no. Cisco doesn't do that. I'm sorry, not Cisco. It's supposed to say just message digest OSPF. Maybe we ought to do it on the global level. So you know what? Let me just exit since we thought, and let's do the global level because Packet Tracer doesn't seem to support the interface. Let's do it globally. So you're going to say area 0. Oh God. You're going to go to router OSPF number 10. And you're going to say on area 0, right? On area 0, the authentication is M message digest, right? That's it. And then type exit. Then you go to the interface right here on the gigabit 0/0, and then you say IP OSPF. The message digest key number 1 is going to be MD5, and the password is going to be Cisco 123. Already, okay, that's fine because we already did it. Let's go to router 2. We're not going to do it to this interface because he's not participating. So we'll go to this interface right here. Got detached because of the authentication. So type exit, and you are going to say router OSPF number 10, right? And you're going to say area 0. The authentication is the message digest, and that's it, right? We're going to exit out of here and go to the interface fast Ethernet 0/0 and type IP OSPF. The message digest key number 1 is message digest number 5. We want and also use the Cisco 123 as the password. All right. And now we should be able to, because now see, came back up, right? Now it's fully loading. All right. Now this guy got detached because he doesn't have the password. So we got to fix him up. All right. So you go in and you say router OSPF, go to router OSPF number 10. And then you're going to say on area 0, on area 0, the authentication is the message digest. And then you go to the interface, fast Ethernet 0/0, and then you say IP OSPF, the message digest key number 1 is going to be using the message digest number 5, which is the strongest, by the way. And then the password is Cisco 123. And he should join in now because now he has a correct password, and it does join. All right, just to make sure, we're pretty much done. Now, all these routers are secured now. You got to have that message digest with the password Cisco 123 to be able to get in. All right, so we did a lot. We ran OSPF. We learned how to not use the wildcard and force OSPF to use it themselves, so we don't even have to figure it out, right? With the quad zeros. We learned how to do auto cost, change the bandwidth on the interfaces, right? We changed the priority numbers so we can manipulate the elections. We created loopback addresses. We configured the router IDs. We changed the hello and the dead time intervals. And we also did authentication, right? By the way, the whole setup for IPv6 is pretty much the same thing. All right. To verify, just make sure you type in show IP routes, and O's are still there. You see that? See this 20 meaning you got 10 plus 10 to reach the network 172. Well, to reach the 192.168.11, right? But for some reason he does not have. Let me see what he has. Do Control Z. I'm going to do show IP route. So he has the two O's, the 11 and the 12. Let's see what he has. Control Z, show IP route. So he has the two O's. See, I don't like this because this should not be the same because this is gigabit Ethernet and this is not. The only thing that I'm thinking about is that this guy is because this is a fast Ethernet. This drops to not a giga. See, they're not even supposed to communicate because this is gigabit and this NIC is not gigabit. So that's why packet traces may be screwing this up somehow. I don't know. All right, let's go back to router 3 and make sure he only has one O. Where is the third O? It does not show up. He only sees network A, but he does not see network 10. All right, I'm going to have to troubleshoot this and figure out why it's not picking that up. But anyway, so that's it. We're pretty much done. We'll take a look at, maybe in class we'll do something with point to point, and maybe we'll practice some IPv6. We'll see. It all depends. And we'll review some of this again with OSPF. All right. So make sure you save this and you send it in with the other 4 questions that I asked you about. All right. So until then, until we meet in chapter 5, we're going to go into now multi-area OSPF in chapter 6, actually. Okay. Until we meet again, God bless.